All right, let's dive right into this explainer. Today, we're going on a journey to completely unravel a tool you probably use every single day. I mean, we interact with artificial intelligence so naturally now that it's super easy to forget what's actually happening behind the screen. And let me tell you, the gap between what we feel is happening and the hardcore mathematics running in the background, it is absolutely fascinating.
So we've all done it, right? You type a prompt into ChatGPT, that little cursor blinks, and a perfectly thoughtful answer just appears. But do you think the AI is actually reading your words? See, as humans, we process text by reading letters, forming words, and instantly attaching meaning to them based on our whole lives of experience. But is the machine doing that? Or is it playing an entirely different game under the hood?
Let's say you ask an AI a really technical question. You might type something like, "Please explain why GPUs can train AI." And the AI responds beautifully. It knows what a GPU is, it understands AI training, and it seamlessly creates this incredible illusion of human comprehension. It literally feels exactly like you're talking to a highly knowledgeable colleague who just natively understands your intent.
But here is the massive secret, and this is a foundational paradigm shift we have to make right now. Computers have absolutely zero innate concept of human language, meaning, or intent. None. To the machine, your thoughtful, meaningful question isn't English. It isn't anything. It is simply a string of unrecognizable characters.
So to bridge this crazy gap between our human meaning and machine processing, the AI first has to chop our words up into mathematical pieces it can actually digest. Because it can't read text directly, it essentially has to translate our messy, nuanced world into a very strict numerical format. The crucial point here is that it converts everything into what we call tokens. Depending on how the model is built, a sentence like "GPUs can train AI" just gets sliced up into smaller mathematical fragments. GPU might be one fragment, can might be another. That's step one, turning our messy human words into discrete, digestible tokens.
But assigning a token to a word comes with a huge caveat. Let's say the word GPU becomes token 15231. Does token 15231 inherently know what a graphics card is? The answer is a resounding no. Just like assigning the number 001 to the word apple doesn't magically teach a computer what a piece of fruit tastes like, right? At this stage, it's just a meaningless ID tag. That number contains zero information about the physical world.
Okay, so if the token itself is basically meaningless, how does the AI actually find meaning? Well, it looks at who that token hangs out with. By chewing through immense amounts of data, the AI notices patterns. It sees that tokens for GPU, CPU, NVIDIA, and training show up in similar paragraphs all the time. Because they share these contextual environments, the AI mathematically pushes their positions closer together in its internal space. It's literally learning relationships purely through proximity.
And what's really wild is how it separates things out. A concept like GPU and a concept like banana end up existing in totally different mathematical neighborhoods. They rarely, if ever, hang out in the same sentences in the training data, so their relationship in that mathematical space is incredibly distant. This distance is how the AI starts to separate categories of meaning, without ever actually knowing what a graphics card or a banana is in the real world.
This brilliantly illustrates how AI relies on things called embeddings to build a giant semantic map. The AI takes that initially meaningless token ID and maps it to a high-dimensional vector. That's just a very long string of numbers pinpointing its exact location. To put it simply, the model is not building a dictionary in its brain like we do. It's building this vast, mind-boggling mathematical space formed by billions of relationships. But wait, even with this incredible map, single, isolated words still aren't enough to grasp the nuance of a full sentence. Because, let's face it, human language is messy. Words change meaning entirely depending on how we use them.
Think about it. The token apple could mean a delicious snack, or it could mean a multi-trillion-dollar tech company. The AI cannot just rely on the token itself. It has to act like a detective and look at the surrounding words. If Apple is hanging out next to iPhone and announced, bam, it's the company. Next to eat and fruit, it's the snack. That takes a super dynamic understanding of context.
And this is exactly where the absolute magic of the transformer architecture comes in, specifically through context and attention. This mechanism lets the AI calculate exactly what relates to what in a sentence. Attention isn't just kind of glancing at the words next door, it is a rigorous, heavy-duty mathematical calculation. When the model reads a vague word like "it," The attention mechanism calculates exactly which previous tokens should be mathematically weighted the heaviest. It's actively figuring out who is related to who at every single step.
So that leads us to a really fascinating question. If these incredible abilities, like mapping massive semantic spaces and calculating attention, aren't just hard-coded by engineers line by line, when exactly does the AI learn this complex web of meaning? Because it definitely isn't learning at the exact moment you hit enter on your prompt.
No, it all happens during the massive training phase. Picture this relentless looping cycle. First, the model reads vast amounts of text and tries to just predict the next token based on everything we've talked about. If it guesses wrong, say it guesses CPU instead of AI, it moves to step 2, calculating the loss. That's just the mathematical gap between its guess and the actual right answer. Then it uses a process called backpropagation to trace that error backward through its whole network. Finally, it updates its internal parameters to be just a tiny bit more accurate next time. And it repeats this exact cycle: predict, calculate error, backpropagate, adjust, literally trillions of times.
So it's never just about a single prediction, right? It's about the sheer unimaginable scale of those trillions of microscopic mathematical adjustments. Only after chewing through all of that does the AI start producing those amazingly accurate outputs that feel so incredibly human. It is deriving context, relationships, and structure entirely from the data itself.
Which brings into focus a pretty stark contrast. Human cognition works by hearing a sentence, filtering it through our own subjective consciousness, truly understanding the world, and then replying. AI operates on an entirely parallel track. Its tokens, converted to embeddings, pass through context and attention layers, which results in a probability distribution used just to predict the next mathematical token. It's totally alien, yet highly effective. Because human language is so incredibly structured and logical, mapping it mathematically produces results that flawlessly mimic comprehension. And that leaves us with a final, fascinating question to ponder. If a machine can perfectly replicate the logic and nuance of our language through sheer mathematical probability, is there ultimately a meaningful difference between perfect prediction and actual thought? Think about that the next time you watch that cursor blink. Thanks for joining me on this explainer, and I really hope this completely changes how you look at your next prompt.